Hello and welcome to my tutorial on set theory. Set theory is really straightforward. You've probably worked with this type of thing in mathematics and maybe other computer science courses, but it's probably worth refreshing through before you work with combinatorics, just so you know a lot of the terms and how these things work. So anyway, it'll just make it easier if you just do this video before going through my other videos in this video series, but I'll try and go through this quick and maybe see if I can keep it under 5 minutes. So sets are just an unordered list, so you could write like the set S as, let's do numbers, like sets of numbers, so we'll do 1, 1, 2, 3, and remember it's unordered, so let's do another 2 here. And then let's make another set T equals, we'll do 1, 2, 2, and then 16. One term you should probably know is a subset, and all a subset is a set that has all the elements in the first one. So T would not be a subset of S because it has a 16, which isn't an S, but an example of a subset of S is if we had the set Q, let's say, and let's make Q equal to 1, 1, and 2. Q would be a subset of S because it has all the elements that are in S. And also, it's only considered a proper subset if it's has less elements than the original set. So basically, it wouldn't be a proper subset if it was just the same. If like a set wouldn't be a proper subset of S if it just had 1, 1, 2, 3, and 2, just like S does. And then there's also disjoint sets. So let's make one more set. Let's make it, I don't know, R equals, let's do this one, 19, 7, and 14. And this set is disjoint with all of these other sets because it doesn't have any of the same elements. So just to go over a few quick things. Also, one more set you should know is the universal set. Universal set. And that's just written kind of as like this fancy U thing. Like that. So, for example, if we were doing numbers, the universal set would be 1, 2, 3, and then it would go all the way up to infinity because the universal set is every possible element in the set. So, if we were doing letters, for example, the universal set would be like A to Z, like if we were doing just one kind of letter. Okay, so anyway. Just a few more things I want to go over is union, complement, and difference. You've probably seen these before. I'm just going to try and go over them real quick. So intersection, and then that's represented by like an upside down U. Like I've said, you've probably seen this working with like graphs in mathematics or something like that. And all an intersection is if you have two sets, like let's say S intersects T, that would be equal to all the places where they have the same elements. So in S in both of these we have 2 1s up here and 1 1 down here, so we just have 1 1 because we're limited to what they both have. And then we have 2 2s here, so we'd have 2 and 2 because they both have 2s. And then we have a 3 here and a 16 here, which aren't in both sets, so we're going to have to leave them out. Okay, and then there's also union. Union, and I mean that's just kind of a normal looking U, and that's just all the elements in the set. So S union T, that would be equal to, so we wouldn't repeat the same elements. for example, in this one, this first one, we wouldn't repeat because we have both of them in there. But this one is in S and not in T, so we're going to put that 1 too. So it'll be 1, comma 1, and then we have 2 2's from T. We also have these 2 2's here, so we're just going to put that in one place here. So 2 2, and then in S we have a 3, so we're going to put that in too. And then in T we have a 16. So it's all the elements in both sets, and you do include the repeats as 1 that are in both sets where they intersect. Okay, so complement is another one. Complement. And all that is a line over the top of the name of the set. So let's say we had complement of S. So remember, the universal set is everything from 1 to infinity. And a good way to think of this is not like in Boolean algebra in the next video, you're going to kind of see how these are similar. So just think of everything that's not an S. So it would be like 1 is an S, so we wouldn't include that. 2 is an S, wouldn't include that. 3 is an S. And then we have everything from 4 to infinity that's not an S, but is in the universal set. So it would be 4, 5, 6, 7, dot, 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 all the way down to infinity. And that would be the complement of S. Okay. And then there's also the difference. You can probably imagine how that's going to work. You just subtract the elements from each set. So let's say we had S minus T. That would be equal to, so we have 1 here, so we'll subtract that. We have 2 2's, and then we have the 16 doesn't do anything because it's not in the S. And then we have the 3, which stays there. So the only thing that stays is the 3, so that would just be like this, I think, right? We would also have a 1, I'm sorry. Because we only have 1 1 in T, 1 and 3. Okay, and that's difference. Okay, I think that's all. So, yep.